Hi, welcome to the video on matter, definition, and classification. So we have been discussing matter in this unit, and it's related to atoms. We know that chemistry is the study of matter, and all matter is made of atoms. But what exactly is matter? Matter is anything that has mass and volume. So if you can weigh it, it's matter. If you can measure its volume, then it's matter. Let's solidify this idea a little bit further by looking at some examples of matter, so things that are matter, and non-examples of matter, so things that are not matter. First example is a lamp. You can weigh a lamp, and you can also measure its volume, and so a lamp would be an example of matter. Whereas light from the lamp is a non-example because you cannot weigh it, and it doesn't have volume. Air in a balloon is an example of matter. Now, oftentimes people think that air is not matter because you don't really feel it. It seems like it's weightless, but actually air is an example of matter. And when you blow up a balloon, that's your evidence, that's your proof, because as you're adding air to the balloon, the volume of the balloon increases due to the volume contributed by the air. Wind, on the other hand, is not an example of matter because wind is just the movement of air, so it's the action. So wind would not be an example of matter. So in this picture, you have someone heating up some marshmallows on a campfire. So which one would be an example of matter and which one would be a non-example of matter? So heat from or the wood on the campfire. And then explain your answer. Pause the video now. When you press play again, the answer will be revealed. So wood is an example of matter because you can weigh it and measure its volume. And of course, wood is also made of atoms. Whereas the heat itself, you cannot weigh it or measure its volumes, and it's not made of atoms, so that will be a non-example. It's not matter. Now, there are three states or phases of matter, which you probably already know: solid, liquid, gas. And you probably also know that you can transition from a solid to a liquid by heating it, or from a liquid to a gas by heating it. So therefore, you can move between phases or states of matter by either adding heat or cooling it down. You can also do that by changing the pressure, but that's a different story for a different day. But did you know there was actually a fourth state of matter? If you heat gas up enough, so you have to add a lot of heat to it, it can transition into the fourth state called plasma. Now, in the plasma state, the electrons and nuclei are separated. And this is actually the state of matter that exists during nuclear reactions. Now, even though this fourth state of matter is important, we're going to focus really on solid, liquids, and gases in this class. So what are the characteristics of solids, liquids, and gases? Well, just looking at the images, you can see that the solid particles are really close together, and the liquid particles are a little further apart, and the gas particles are really far apart. You would also notice that the gas particles pretty much take up the entire container, whereas the liquid and solid particles do not. So what exactly does this mean? Well, first of all, some characteristics of solids. They are non-compressible. Because the particles are really close together, you can't really force them any closer. In terms of their volume and shape, they're both fixed, meaning that whatever the volume is of the solid that you have, or its shape, it's not going to change no matter what container, size container, or shape container you put it in. So when you're thinking about a solid, it really doesn't do it much. You really can't change its volume or its shape just by putting it into a container. Liquids, like solids, are also not compressible. They're a little bit more compressible. You can sort of move them a little bit closer together, but they're not very compressible because, again, the particles are still pretty close. But one thing that's different from a liquid than a solid is that the particles can actually flow and move over one another. And that's unlike a solid, where the particles, they really are fixed in place and they just sort of vibrate, sort of shake in that place. Whereas liquids, they can actually flow. And because they can flow, they can fit their shape. The shape of the liquid will take on the shape of a container. So if you have, let's say, a heart-shaped container and you pour a liquid into that heart-shaped container, the liquid takes on the shape of that container, heart shape. The volume, on the other hand, of a liquid, just like a solid, is fixed. So let's say this container is 5 milliliters and you pour in 1 milliliter of liquid, it's going to remain 1 milliliter of liquid no matter the size of the container. Finally, with gases, you'll notice that they're really far apart, and gases, because they're so far apart, they are compressible. So you can compress them, sort of compact them. And also their volume and shapes are not fixed because they're so far apart. So their volume, they're going to take, since they spread out throughout the container, the volume will take up the volume of the entire container. And again, the shape will also take up the shape of the container. All right, so how do we classify matter? Matter is classified by what it's made of and how or if it can be separated. So let's take a look at some examples of matter. Here we have a bunch of different types of matter. We have a helium balloon, this is a brass instrument, milk, granite, sulfur, all sorts of things. Now, the first way that we classify matter is whether it's a pure substance or a mixture. So to classify matter as a pure substance or a mixture, the first thing you ask yourself is, can it be physically separated? If it can be physically separated, then it's a mixture, like these examples here. And if it cannot be physically separated, it's a pure substance. Now, when you hear the word mixture, it probably already gives it away what it means. A mixture means it's made up of 2 or more pure substances, whereas a pure substance only has one type of substance in it. But what does this physical separation mean? So let's take a look at examples of mixtures and pure substances, and then we'll talk about how they're separated. So air is an example of mixture. As you can see from the pie chart and also from this image here, air is made up of different types of gases like nitrogen, oxygen, argon, right? So all those different types of gases make up air, and they're all mixed together. Whereas on the other hand, this tube of argon is a pure substance because this tube only contains argon gas. There are no other types of gases in here, so that's a pure substance. So how do we separate mixtures and how do we separate pure substances? So mixtures are separated by physical means. And when you think of something that's a physical separation, it means it doesn't change the nature of a substance. And filtration will be an example of that. So if you have, let's say, a container of sandy water, a mixture of sand and water, if you wanted to separate the sand from the water, you can filter it because the particles have different sizes. Now, in doing so, what you'll be left with is water and sand. You did not change the water into something different. You did not change the sand into anything different. All you did was separate the 2 substances. Another example of a separation that can be used for a mixture is distillation. So distillation is when you're separating things based on their different boiling points. So things that have a lower boiling point will boil off first, and you can sort of collect it as your distillate here. But once again, when you're doing a distillation, you're not changing the substance. So if you are trying to distill, let's say, a salt water mixture, and what you want to have left in the container is just salt and all the water go over on the other side, then you still will have water and salt. They wouldn't change into a different compound or element. On the other hand, for pure substances, when you separate them, they have to be separated by chemical means. Now, when you see the word chemical, like whether it's a chemical change or a chemical property, chemical implies change. So change begins with a CH and so does chemical. And what do I mean by change? If we look at an example of separating water, water is H2O and it's made of oxygen and hydrogen atoms. If you wanted to separate that, what you would have to do is use a technique called electrolysis, where you sort of put a current through or pass a current through the water. And in doing so, it breaks apart these bonds. And the bonds then reform to form hydrogen gas, H2, and oxygen gas, O2. And hydrogen gas and oxygen gas are not water. So you have now changed water into 2 different things. And so that's why it's a chemical separation, also known as a decomposition. Okay, so now that we looked at the differences sort of between a mixture and pure substances and what do we mean by physically separated, let's take a deeper dive into mixtures. There are 2 types of mixtures, homo and heterogeneous mixtures. Now, homo means the same and hetero means different. So when we say a homogeneous mixture, it looks the same or uniform to your naked eye or under a microscope, and a heterogeneous mixture looks different under a microscope or to your naked eye. So here we have some examples of homogeneous mixture, which is a cup of tea. If you look at that cup of tea, you can't see the tea parts and the water part. It all looks like one thing. On the other hand, this silty, sandy water, you can see the silt or sand part, and you can see the water part. They're separate, so that's a heterogeneous mixture. Now, I wanted to give you some examples of homogeneous mixtures that don't involve just liquids solutions. And the reason why I want to do that is because a lot of times when we give examples, we oftentimes just focus on things where you're mixing things in water. But there are other examples of homogeneous mixtures, like brass. Brass is a homogeneous mixture of copper and zinc. We call those type of mixtures metal alloys. Air, like we mentioned before, is also a homogeneous mixture because if you're looking at air, you can't see the different types of gases. It all looks like one thing. And the same thing with oceans and lakes, they have oxygen dissolved in the water. So even though there's not like a ton of oxygen dissolved in water, there is still some in there, and you can't see the oxygen part or the water part separate. So that's what makes it a homogeneous mixture. All right, try to see a few. Which substance is a homogeneous mixture? Select all that apply. Pause the video now. When you press play again, the answer will be revealed. All right, the answer is C and D. Both steel, which is shown here, is a homogeneous mixture. It contains iron and carbon. It's an alloy of iron and carbon. And black coffee, when you look at black coffee, it all looks like one thing. Now you might be wondering, well, what about milk? It looks like one thing. Well, remember, a homogeneous mixture looks uniform with our eyes or under a microscope. And if you take milk and put it under a microscope, you can actually see the sort of the fat globules and then like this clearer liquid. That is a heterogeneous mixture because you can see the different parts. So milk, if you put it under a microscope, is heterogeneous. All right, let's move in now to pure substances. So there are two types of pure substances, compounds and elements. And we're going to talk about what those are. So an element is matter that's made up of one type of atom, whereas a compound is made up of two or more types of atoms. So let's look at some examples. Helium and oxygen are both elements. So helium just has a helium atom, and oxygen has two oxygen atoms. Even though there are two atoms here in an oxygen molecule, it's still the same atom, so it's an element because it's only one type. Where compounds are made up of two or more types. So if you look at water, for example, it's made up of hydrogen atoms and oxygen atom, and so therefore it's a compound. Similarly, sodium chloride is made up of sodium and chlorine atoms, so it's a compound. Now, the other word you may hear me use is the word molecule. So what exactly does that mean? A molecule is a chemical made up of two or more atoms. And these atoms could be the same type or different types. So if it's the same type, you have an element, and if it's different, you have a compound. So all of these are molecules. Now, all compounds are considered molecules because since a compound has two or more types of atoms, it definitely will contain more than one atom. So it's definitely a molecule. But not all molecules are compounds. Some are going to be elements like we have oxygen here. And on the flip side, not all elements are molecules. So helium and other noble gases, they don't form bonds, and so therefore they are not molecules. But they are still elements. Okay, so just taking a step back, how is matter classified? The two main classifications are mixtures and pure substances. And a mixture has two or more types of pure substances that can be separated physically, whereas a pure substance only has one type and it must be separated chemically. If you want to separate it into its different atoms or into its atoms, it has to be done chemically. So there's a change there. Of mixtures, there are two types, homogeneous and heterogeneous. Homogeneous looks the same or uniform under a microscope or to our eye, and then heterogeneous, it looks different under a microscope or to our eye. And for pure substances, there are two types. Compounds is made up of two or more types of atoms, and an element which is only made up of one type of atom. Okay. we have two more CFUs. In this CFU, I want you to label each sample of matter as a pure substance or a mixture. And after you've identified whether it's a pure substance or a mixture, I want you to talk about the type of mixture it is. Is it heterogeneous or homogeneous? Or the type of pure substance it is. Is it an element or compound? And to sort of help you out with this, I gave you the chemical formulas for both liquid nitrogen and baking soda. All right, so go ahead and pause the video now, and when you press play again, the answer will be revealed. Great, so liquid nitrogen is a pure substance, and because it's only made up of one type of atom, it's an element. Blood, remember, if you look at blood under a microscope, you can see the different parts, like you can see red blood cells and non-red blood cells, and so that would be considered a mixture. So it's definitely a mixture. It's made up of more than one pure substance, but it's also heterogeneous because you can see the different parts under a microscope. Steel, remember, is a metal alloy. It's a homogeneous mixture. And baking soda, which has the formula NaHCO3, this is made up of different types of elements: sodium, hydrogen, carbon, and oxygen. So this is a pure substance, but it's a compound. It's not an element because it has different types of atoms. All right, last CFU. For each pure substance, I want you to check the box that best describes the substance. There may be more than one. So for each one, you're going to see if it's a molecule, element, or compound. Pause the video now. When you press play again, the answer will be revealed. All right, CO2 is a molecule because it's made up of more than one atom, and since the atoms are different types, it's a compound. S8, sulfur, is a molecule because, again, it's made up of more than one atom, but because the atoms are the same types, they're only sulfur atoms, it's an element. Argon only has one atom in the structure there, so it's not a molecule, but it is an element because it's only one type of atom. And then the last one, acetaminophen. Once again, it's a molecule because it's made up of more than one atom, and it's a compound because it's made up of different types of atoms. All right, in the next video, you're going to learn about matter and its properties. So that is it for this video. I hope you found it helpful. Have a quality day.